Hi everyone, welcome back to my YouTube channel slash page slash channel and slash page. So today I'm going to explain about regression, what regression is, why it's important in machine learning and how it works using simple examples here. So let's say we have a question like how strong my character would be if I increased the attack and speed, for example. So that question is regression basically. Right, regression is a supervised learning model, which means that we already know the correct answers, our labels, our target variables, and we're gonna use them to teach the model, right? So in regression here, our goal is pretty simple. We wanna predict some value here. We have a data set, and wanna predict some value, and use features. So we use all the other values in the table to predict it. So we can use to predict like prices, salaries, damage score, power level, which is my example here. This value is called the target or the dependent value variable because it's gonna depend on the other values to predict, okay? So let's gonna take a look at our table here. Here, the FC, it's gonna be our target value, our feature. In this example, we will try to predict FC. All these stats here, features that will be used to predict FC. So this relationship between the inputs and our output is what regression is. Basically, what we're saying is, given these stats, what should the FC be? So there are several types of, there are several types of regression, but we're gonna start by simple and multiple regression. It's basically the same thing, except that the simple regression uses one single input to estimate the output. So for example here, we're gonna use like just one feature. It's gonna be either attack, defense, speed, or magical attack, magical defense to predict our FC. And in multiple regression, we're gonna use multiple features. So we can use all of them, or we can use 2 or 3, 4. It's gonna depend on the relationship. We're gonna take a look at that after when we study the multiple regression. And both of them can be either linear or non-linear. Linear is when the relationship between our x-axis, our features, and y-axis, the label is linear. And non-linear when it's not linear. Maybe it's curved, polynomial, exponential, or just not linear. Okay, it's not a diagonal line. Here we have some applications and some algorithms to regression. And now let's see simple linear regression more in detail, right? So as I said before, it models a linear relationship between an input and an output. That's another example using carbon emissions here. And we can predict these carbon emissions by using only one feature. In this case, we're using engine size here. So basically, a linear regression models a relationship like as x increases, y increases as well, or decreases, right? As long as it is a straight line. We can represent it mathematically with this equation, where theta 0 here and theta 1, the coefficients. Theta 0 is the intercept, the y-intercept, and theta 1 is the slope, or the wave, right? So like it's the rate of change of our predictor. It can also be represented with W or theta is the same thing, it's just a different notation. So finding the best fit, okay? This red line here, what I call residual errors. The bigger they are, the poorer our model is. So we aim to minimize these errors. We have some ways to minimize it, and we can measure it using the mean squared error, or MSE. And this approach here, where we minimize the mean of all the residual errors, is called ordinary least squares regression. So what I mean by minimizing the means of the residual errors is that we don't want to like make 1 or 2 residual errors disappear. You want the average of all the residual errors here to be the less possible, right? The smallest as possible. So the OLS, or ordinary least squares, give us a formula to compute the slope. And relax, okay, we don't want to do this computation. I actually have many tools that do it to us. It's just good for us to know what conceptually it is doing, okay? So we're calculating the statistics from the data. Basically, this n is the number of data we have. We're gonna sum our target and our input and output, and we're gonna take we're gonna calculate the mean, right? Taking the average and then multiplying the sum. But as I said, don't worry, we just gotta know the theta 0 and theta 1, and basically theta 0 and theta 1 is taking the mean of all the rows here in our data set. So the OLS regression is not all good, okay? We have some pros and cons. It's very easy to understand. I could explain to us in less than 5 minutes maybe. It is fast, okay? It doesn't require any tuning. So it's just computation, and what computers is good at is to do computation. So it's pretty fast, okay? We don't have any hyperparameters. It is mainly great for small data sets, but the cons is that it only works well for linear relationships. So if you have a line here that is non-linear, it might not work that well. And this one is very sensitive to outliers. And I made a hands-on example here. It's basically instructions, but I run a code with a real example. I'll be posting on the next video. And basically that's it. So regression is one of the foundations of machine learning. Here we learned inputs, outputs, we learned linear relationships and errors, and some best fit, okay? So next I will explain I'll go through this code I made, and thanks for watching. See you later.